While we're getting started, let me go read my messages, oh boy. Copy URL, stream, boom. Everything looking good in OBS? I think so. My poor nose. So, get started with any of the loops. I can do defer real quick. Defer can do an entire statement. Go to return. Did I not put defer? I did. Let's do defer. Alrighty, so what we've got do and for, and then while at the bottom. While is the easiest, for sure. Do is probably even easier, if I'm honest. First. Hello, sorry I'm late. I just started, you're not that late. We've parsed one thing. Body is parse stmt expect. that. So I think that parses an entire do loop. So I want to make sure I eat the first token. I'm gonna just leave this shorter. Text node body syntax token. Like that. Defer. This is defer to do. This is while. Body is body. Hoi. Okay, do loop, easy enough. I might add those later, just being lazy. Let's go ahead and test that both of those work. So defer foo, defer bar baz, and then do foo while bar plus baz, do foo. Do I? Oh, you're right. Thank you. Copy pasta, copy pasta. Okay. No errors. Defer foo call, yep. Defer bar and baz in a compound, yep. Do loop, do foo, while bar plus baz, cool. Do foo, while true. Perfect. So git do while. I'm not going to be super loud talkative. My sinuses are fucking with me. I'll still interact with chat if you guys have any questions or anything. But after lunch, my sinuses went all whack, so my throat's a little bit ugh. Boy. Okay. So while. Let's go build out the while. Okay. Then I actually want my nose. That. Okay. Then this is our condition. while condition body else body. What's it mad about? Oh. New, like that. So then we should be parsing a while. Simple while true. Oop. While false bar else as. Not what I wanted. No errors while true. Compound. Do foo while false. Compound and expression. Okay. Boom. That gets us that. So then we have 4. Let me go check these off actually. For okay. So 4 is going to take some time to get right. We will eventually want to do all of this shenanigans. And then return syntax stmp to 4 with at least the token 4, at least the body. So we have a couple of different forms. Let me go open up the old tests from Laye. Okay, I'll probably want to support this while here, which I can actually do real quick now that I'm thinking about it. No, we'll do it in a second. So yeah, we never did that. So we'll get to 4 each eventually. Maybe soon. Okay. I'm curious what Serraid was doing with 4 each. So I wanted to steal this syntax from him. I never got around to it. But I don't support natively multiple declarations. So this would have been like a hand-wavy enum I, comma, type of array element in array. Which I might still do. But if you didn't want I, then V doesn't have a type. We may still have to leave for each loops for a little while. Let me go see real quick. where repositories source. Did he have an older source? Source and IR, that's what it was. So in here, I was looking for tests, maybe. Yeah. Yeah, so that's just exactly what he does. He just doesn't require a type at all. I might have a really tough time figuring out how I want to do for each loops. So we're definitely going to leave for each on the table for now. It's not something I'm going to be doing right away. So regular for loops have a couple components. So we do have a condition, which can be null. So in this case, I'm just actually going to say this needs a couple things. Condition, we have an initializer, condition, and an increment. We have a body with no else. So that's what we're going to do. And there's no else. Okay, initializer is not null. That. Addition and increment. That's all I need for a for loop. So let's do that. Then now here's a problem. Not really a problem. I'm just going to have to manually check for declarations here. If we're not at a semicolon, rather if we are at a semicolon, we're just going to skip something, but that's fine. Expect semicolon here. Yep, hello. The hardest thing to parse, the for loop, is in progress. So var I'm going to parse an expression in. Now here's the thing. here's the thing. Here is the thing. I never considered this. But I don't know how I'm going to do this. If I check for declarations, then I get declaration parsing for free. Except this also does functions. And I don't have a way to stop it consuming the semicolon. So I might have to check for declarations myself. Let's walk through here and see what check for declarations is actually doing. Right. Kind of need that. I could duplicate the work. I could add a new context that does some of the work here regardless. This is an issue I didn't expect to have. All right, I gotta think about this for a second. How do we, to illustrate problem? Oh, I haven't done this. I need to add that to my to-do. Right, so if we just parse any old declaration, one, it's going to consume this. Two, it's going to allow us to do this, not that, this, which we don't really want. And three, this is all happening in the binary expression parser. So if in this case, it doesn't matter. The case that it matters is star or ampersand. Ugh. Star causes problems. Fuck, I don't know what to do for this. I may have to put off for loops so I can spend some time off stream thinking how to solve this. I guess I could just add an additional because these, I don't want that. Wait, what's the problem? Parsing the first part of a for loop. I can't directly rely on the existing declaration parser because this could be a declaration or an expression. And we currently handle that in the statement parser, where right, I don't have a way in the parser right now to parse this part of a for loop. And I don't really want to duplicate all of the work that goes into parsing a declaration when it could also be an expression. The biggest problem is this semicolon. And the second biggest problem is I want to try to disallow parsing functions, right? because that just doesn't make sense. So I could pretty easily add a flag that says, hey, don't parse a semicolon. And I could probably pretty easily do the same thing and say, hey, also just don't parse a function at all. I might just do that. I haven't introduced nil yet. Hold on. Nil needs a literal. God, I'm forgetting all sorts of things. Expressions. Nil. Can't forget nil. Nil is not done. So I have this parse context. I think what I'll do is I'll do this. And then here, if it's a check for declarations or parse context is equal to for loop initializer, then we do the same thing. If we're at a semicolon in both cases, it's fine. If we're at an equal in both cases, it's fine. But then here, we only want to do this here. If we're checking for declarations. So then, the next thing I want is here, we need a here I want, I think I want to remove the semicolon from here because it could be null, I guess. That, and then the decal binding. This can be null, this can be null. That. So then, here, that's a problem. Up here, this will always be true. Then here, for the initializer. So this is initializer. Expect the semicolon. Then, if we're not at a semicolon, condition, we parse default. Expect a semicolon. Then, if we're not at close paren, we parse another expression. And this is increment. The body is parse statement. So then for loop becomes token for initializer condition increment body. Does that work? So if int foo is 10, but then also if we just have int foo, foo is 10. This is parsing an expression, not a statement. Shit. Do I have... this and then this So then both of these need to have a nullable semicolon. Like that. Can you in C++ use switch cases for Elixir, and is it a good use case? I mean, yes. I do that in like everything. Do you mean anything more specific than that, or? Okay. So then in here, what I want to do in the initial history is if current token kind is assignment operator, and really I don't even have to do that, but I should. So then that should work, and then I should also be able to say for foo something like this. I should be able to say for foo and for foo and for nothing. Okay. Whoa. Well, okay, so 214. What the heck? What the heck? Yeah, int foo is fine. We get fucked up again in line 6. Looking for... Oh, because I haven't done plus plus yet. That doesn't help. Let's just say foo instead of foo plus plus, so I can try to see if that reduces the number of errors. It's not going to reduce all of them, because we've still got... Yeah, so line 6 parse is just fine. So now, it's just line 2 that's failing. And it's failing pretty hard. What the hell do I do about this? So it expected a semicolon on 214. So at the keyword, or at the identifier foo. So in 4, I really need to try to get this set up in the debugger. Hold on, launch. this be an arbitrary task? Build, okay. Args, build this. So what I want is R win x64. That's what I want. So if I try to put a breakpoint and launch this time, what the fuck? Okay, so tasks, we're gonna .NET build bootstrap acquire driver. Do it again. Okay, I can debug finally. I've done this whole thing with no debugger. Oh, I didn't set the, what the heck? Okay, let me just try to parse this. What's going on? Oh, because it's totally launching a different thing. What is it building to? I saw that it was going to build somewhere else. Now I gotta go find this shit. Are we in debug? We are. x64 debug .NET 8. Okay, so it's missing this after .NET 8. It should be the up-to-date version now. What the fuck now? This hasn't been updated in almost a week. Am I running in here? Damn. Bin debug net, so it's just not in here. Okay. Now. Okay, so we get 4, we get the open paren. So now we are at int. I'm just going to see what the initializer returns. We'll step into it later. It's going to return true. With no children. Type int, built in. It didn't, because it's parsing an expression. But no, this should be fine. Because it should be parsing a, Oh, wait, hold on. Hold on. I thought this would do more, but it won't. That's what I needed. Okay, let me go back to here. So, if the initializer is a declaration, then I do nothing for now. Else, if initializer can be type and rat an identifier, then initializer equals parse binding starting at name. Initializer false. Right? It's already a declaration. Else do that. Does that work? For int foo equals whatever. Expression binary foo is less than 20. Foo, which should be plus plus, empty syntax compound. Okay, I think that fixes that. So then if I bring everything else back, no errors, and I checked all the other ones to look correct. So as long as this line 6.1 after the decal binding looks good, statement assign, that's good, foo equals 10. Binary, foo is less than 20. Okay, I'm gonna git AC, add and commit. So now let's go quickly to the while loop and say syntax node condition is null if try advance token kind open paren. Oh. I think for while, maybe it's not a good idea to have that in the first place. I'm gonna leave it like this. We're just gonna leave it like that, that's fine. For each will come later, because I still don't know what I want to do for a for each. Then, maybe that. We have all the declarations left, and I needed to add plus plus and minus minus. So then, let's go to So then in the continuation here, I can just do case plus plus and case minus minus. And one thing I want to do is in here, this is expert unary. This should be prefix, unary prefix, and then I can do postfix. And for shits and giggles, we invert the order. Like that. So then, all I've got to do is say var token operator, assume return new syntax postfix of primary token operator, and we should still be able to parse primary expert continuation like that, which should give us plus plus and minus minus. So if I do both of those, not that, this, and we have postfix foo minus minus and postfix foo plus plus. Good enough for me. Okay. So now I have some declarations to do. A lot of declarations to do. I wanted to try to get closer to setting up Sema, but I don't know how many of these declarations I'm going to be able to work through today. I don't have as much stamina as I was hoping for. So we're going to go back to top level, parse top level syntax. Why are you saving the while do tokens? For shits and giggles, basically. I use those tokens for the location information for the syntax node. It doesn't hurt to have them around. I'm being a little bit lazy and not storing every token right now, just some of the important ones. If I think I need all the tokens, then I'll go back and store them. I've got access to almost all of them. I only have to get a handful out of some of these parsers here. They're not strictly necessary, and most of them will get lost in Sema for now. I can always add them back to Sema pretty trivially if I need to. I just want to make sure the design supports me storing all the tokens in case I need them. I don't need them for the compiler on its own, but I might need them for other things, depending on how far we take this Bootstrap compiler, because I might just say fuck it and not go any farther than the basic compiler driver. Okay, so I did static if off stream, and I have some things to fix up for static if before we get to Sema, because it has to do with imports. I need to be able to collect imports in the correct locations. It doesn't matter for Laie imports. It does for C, and I also need to get the constant evaluator set up so that I can only pick the correct branch for a static if. God damn. I didn't expect to be this tired. This might not be that long a stream then. I might have to do more later this week. So we've already done import declarations. Let's do... enum would be pretty easy. Alias would be basically trivial, I think. Test is going to be nice. These last ones, while technically not difficult, are going to mean I have to change some of the function signatures for parsing each of the things that consume them. So I might actually start with them. They're going to affect all the other things. So let's lay them out. We have template. Template will be the first thing we care about. And we have export. And actually, I'm going to do that out here, right? These will be attributes. I think that's what I was calling them. Yeah, attributes. And then also, those are the two things I'm going to need. So if I advance this dot template, then we can parse a template argument list. So that's one thing. Then after we've parsed templates, we can say, I don't think I need to parse any of these. Maybe inline and discardable. Most of these I don't need. Pure and impure maybe. For nested functions like export, foreign, and callconf. Callconf might matter, but probably not. Most of these are for top level functions. For nested functions, I'll probably still support them and then just discard them in Sema, with errors as applicable. So we will probably say right after here. Private syntax attribute. It didn't do any attributes yet. Do I have export? No. Foreign? No. Syntax attribute. Parse decal attribute. That's one thing we'll have to set up. And then I read only list of syntax attributes. This, which is solid, we're then going to need, let's just go ahead and put this in its own thing. So in syntax attributes. Abstract class this, which will need a location, syntax node, location. And it won't do anything in particular. So I can actually just do that. Okay, so that should fix up this. Yeah. Okay. So then what I can actually just do here is say, fuck it. Parse attributes. Straight up parse decal attributes, which means this can be one. And then we have a couple of things to do in each of these cases, but we'll handle those in a second because we're going to not even get there. We have a few kinds of attributes we want. God, I am so tired. My bad. Public sealed class syntax attrib. I'm actually going to change this because of course I am. Syntax attrib. Attrib foreign. Okay, so that's that. Name. Then get is going to be token name is not null. Token foreign token name. Otherwise, come on, fingers token foreign like that. So that's our foreign attribute. Something that is much easier is going to be export. Okay. Export, let's see. Foreign export inline and discardable are also easy. Okay. Then pure/impure, we're not sure which one it's going to be or if we do either at all. Calling convention is the only other non-trivial one, and it'll have some of this information. So we're just going to say token call conv We don't need this. We don't need so then let's call it token kind, which will be not nullable. That's our calling convention. That should be all that we care about right now. Oh boy, okay. So what we're gonna do is while current token kind is foreign or callconf or export or inline or discard. Oh, that's something else I didn't add, was the discard statement. Okay. Then, okay, while it's any of those, which you want me to do like that, then we can say switch. Oh, wow. Switch. At current token location. Current location actually exists. That case foreign, dollar token foreign equals consume try advance literal string dot var token name return new attrib foreign token name. Easy. Then case token kind export return new syntax export consume, which we can do for inline discardable case callconf. Then for shits and giggles, let me actually make the casing the same. For callconf, we need callconf expects token kind open paren close paren return new syntax callconf token callconf, and then I need token kind, which will just be expect identifier. And we'll check what that is during sema, probably. I could check it here, it is syntactically knowable. So I'll put a to-do, maybe check if this is a valid calling convention here, and store the enum value instead. Okay, so then we should be able to parse all of our attributes. So then attribs.add parse attrib. Why wasn't it happy for a second? I don't know. So now, anywhere that we construct a declaration that can have syntax decals here, anywhere that we construct a declaration that can have attributes, we need to add that. And to keep it from getting too big in the constructor here, I'm going to add public required read-only list syntax attribs get init and public required syntax template parameters. So, okay, so then I need to come up here. Okay. Then we'll have an actual template parameter syntax, probably. But what we care about now is, let's see, do this. Anywhere that we construct these now needs to take them in. So decal function needs template params. And what's the last one? Attributes. Is this. So we need to be passing these around. So like this. Okay. Then this also needs it. Then where's the binding decal as well as here. Binding decal is going to need the same thing. Decal binding here. It does now. Come on, you can do it. Okay. Okay, and then way the hell down here. These can all take null, empty. Okay. That's good. This one is for it can take null and empty. So then in here, I need to grab access to this here. Params, attributes. That. So then way the hell back down here. This one, if we're parsing syntax and statement context, null, empty for now. Perfect. Then null, empty. Okay. So then we're all the way up here. Template parameters, attributes. Template parameters, attributes. So now, we don't have template parameters yet, but I should be able to say export foreign, I don't know, printf, or something, printf2, electric boogaloo, call conv cdecal, and for shits and giggles we'll say inline discard double to test that all of them show up. Void my printf better. Now, something else I want to do is back in declarations here. If template params is not null, we'll return that for each var attrib in attribs. We'll return attrib, and then do the same thing right there. Okay. Then in test. Then in test. Okay, it's a function attrib. Export foreign call conv cdecal inline discardable void printf. Okay, perfect. I say start because we only got through attributes. Template parameter parsing will be one of the next things on the list, but let's go knockout bonk, 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 bonk. Okay. Okay. So let's template something. Template. We're going to do 3 different kinds of template parameters. T on its own, var u, and i32v. And those should be the only 3 things we need. And we might want to support default values eventually. I'm not going to bother parsing it right now, I don't think. Maybe I parse it right now. Right, so here's something without default values. The reason I'm not sure I want to parse it right now is I'm not sure how the syntax is going to be for type of. I will want a type of. And actually, hold on, let me pull something up real quick because, for example, Odin has this. I was looking at Odin for some things, but Odin lets you do shit like this. So I was looking at specifically OS, but it's declaring the type of its OS enum, which is this, based on the built-in Odin OS constant, which means you wouldn't have to define these kinds of built-ins in Laie directly, unless you needed to. So I need to consider if I want to be able to do like alias Odin OS type or Laie OS type equals type of Laie OS, for example, which might look like Laie OS kind, for example, equals type of Laie OS. Is that how I want to use type of? Maybe. And that would mean that template parameters could also use type of in the same way. So in context of compile time known things which won't make it into the final binary, type of would be would have type, like it would be a type. But then in context of if ever I want the runtime type information of something, like if I had vec2 foo, right? And then I could say var foo type is type of foo. Then this would be a runtime type. I think that would make sense. So if that's the case, then I could say by default T, I mean, like the syntax here would just be F32. So I wouldn't need that in templates necessarily, but I would need it here, question mark. That does bring me the question, if ever I want to say, instead of do this, do I want to say type of foo var equals foo? Now, again, I know I have var here, so I don't need that. It's inferred. But should I allow it? Is a type of expression a valid type? Because then I could have my printf better with a type of foo. Right? So type of might be a valid type. That's not a terrible idea. Maybe? Mulling over a lot of options in my head here. Because then I could also have function pointers where I don't have to have the delegate type. Right, like I'm planning to have delegate void, I haven't put the keyword in yet, but delegate void callback, for example, that takes some raw data or something, and that's the word callback is now a function type, just like in C#. But I could also just type of something instead. I don't know what I'd have here as an example. But I could say like some built-in callback that exists, and then I could be like void register custom callback type of built-in callback. Right? Yes? That doesn't sound terrible? So either this or this. Either of the two? Both of the two? I might have to add type of. So types. But type of is also an expression. So just to make that clear, it's also going to go up here in expressions. Okay. We're having ideas. So yeah, if T is F32, U is, I don't know, F2, and V is 10 plus 20. To make sure that we're parsing actual expressions, not just primaries. I just realized I also don't have size of, align of, offset of either. So we have a few more expressions to do as well. I like type of, I think. I think we want type of. Okay, but let's deal with that in a second. That'll remind me I want to do it soon. I want to take a quick break to see if I can keep programming. I'll be right back. Get some water, probably. Take a quick walk around the apartment, see if I wake up. If I don't, then we won't be going for too much longer. But we'll see, we'll see. I'll be right back. unbreak. I am still very tired. So we'll try to get these template parameters done. And then after template parameters, I think it's time to go. Okay. Where are we at right now? Nowhere. That's good. So back in declarations, we have template parameters. Syntax node. So we can do type, location. So vanilla type, a duck type, okay, that's still fine. And then the value is going to have syntax node type and then for all three of them, I'm just going to put that up here. Syntax node initial default value get int. So then really I don't actually like that. I don't like that at all. I don't like that at all. I like that, it's fine. Do that. Makes everything bigger, but it's okay. So those are the three things we want. Then, water is good, stay hydrated. Then, we just need to be able to parse these. So, this now needs, I read, only a list of syntax template params. Okay, that does that for us. So then do this. that. Then. We want to parse delimited. So what I should really do then is just say var this is parse delimited, parse template param singular, like that. Then we're going to say the delimiter is a comma. The expected is then allow trailing as false, token kind, semicolon just in case, token kind greater otherwise. So then I don't have to do this, we just do that. So then to parse a template parameter, we want to say if current token kind, so if we're at an identifier and either, if we're at an identifier and we're either at an end of file, a comma, right, I think I can just do this here, a token kind comma, token kind greater, right? If we're at this, or this, then return new template param type consume. Right, and it's not going to have a default value probably. To get a default value, we can probably say default value equals try parse default value. So that's sure. Syntax node, try parse default value. If not try advance equal, otherwise return parse expression. Here's the problem, we don't want to do that. Default. We want to say bool is type. So this is a type, true. So we're going to say is type parse type or parse expression. Easy enough. So then I can say else if at token kind var if consume if try advance token kind var out var token var, then we can return new syntax template duck type token var expect identifier and try parse default value. Also a type. Else var type parse type x var token name is expect identifier. Return new syntax template param value token type token name and this false. Okay, so that should give us template parameters and default values. How lucky am I going to be that that just works? Oh, you know what I forgot to do? Parse template params needs to expect less greater. Expected greater. Oh. That's a good point. So when we parse, I'm going to, instead of saying default, template. Instead of template arguments, within template. We'll do that. So it'll work for both. Interesting. How did we get there? Which one is it? 325. Here. What the heck? Why? 325 is right there. What the heck? I didn't get lucky. What do we do with this? I just realized I never zoomed in for you guys. That sucks. So we have two problems. Let me go back to template params. Here. Parse delimited. Oh. Well, that's why, because I just fucking didn't do that correctly. Expected an identifier at 612. So... what the heck? How much do you want to bet that this is initialized in a different order? So I can't do my fancy like this. Then var token name is consume to do this beforehand. If I do this, does that work? Expected an identifier at 612, which is still right here. Why? Oh. That's fine. Now there's no errors. Okay. Okay, I think that's that. And I'm going to call it there so I can go relax. I was hoping to get a little farther, but we added a couple of new things to do in our expression and statement and whatnot parser stuff. We're getting really close. I wanted to get some more of these done, but we've done the hard work of getting these declaration attributes out of the way, as well as the template parameters. So Now I just have to do the trivial work of parsing whatever's left here, which should not take long. And then we're good to do module import handling, update how we're doing C headers, because that's kind of fucky right now. And then do sema. I'll start filling out sema pretty soon, the to-do list at least. But for now, that's all I got. Everything is synced up to the repository. You can find that in the description. Also in the description, you can join to be notified in Discord when I go live. I talk with a bunch of cool devs, keep up with what I do off stream. Thanks for stopping by, though. I'm gonna go maybe nap or something, I don't know.